Hi students. So today I will learn Coulomb's force, right? Already I discussed Coulomb force and all the applications, no? So and some questions, no, in part 1. So here in part 2 different type of problems, no, which was not covered in part 1. So because part 1 and part 2 combined it is becoming lengthy, so that's why in the part 2, so all the different type of model questions, no, we can cover based on the Coulomb's law, right? So if you did not watch, please watch Coulomb's law, electrostatic force, first part, right? Clearly I explained everything on in that one, no? So I'll come back to this second part, right? So now let us see. I'll review this one, no? Therefore, what are the formulas, right? Coulombic force. What is the Coulombic force? Now quickly I will discuss, no? So the force between the 2 point charges. What will be the force between the 2 point charges? No? K Q1 Q2 by R square. Clear? So K value already you know it, no? Therefore 1 by 4 pi epsilon naught. So therefore this value is nothing but a 9 into 10 to the power of 9. So this is in the air, right? So similarly if they are kept in the medium, so therefore here you can write down 1 by 4 pi epsilon into Q1 Q2 by R square. Clear? So this it will be the force and it is a vector quantity. So in vector form, therefore you can rewrite it as, so like this in vector form, no? So 1 by 4 pi epsilon naught into Q1 Q2 by R square in R cap. R cap, if you know the unit vector. So if you know the unit vector formula is what? R vector by R modulus of R, no? So you can rewrite it as F is equals to 1 by 4 pi epsilon naught into Q1 Q2 by R cube into R vector. So this is in the vector form, no? So also we discuss the charge, no? Charge is equals to Q is equals to N into E, quantization of the charge, and conduction, induction method, friction method, law of conservation of charges, no? So quantization of the charges, no? Additive property of the charges, no? So we already discussed in the part 1. So based on these applications, all these forces, no? So we'll do the questions in this video, no? All the different model questions, no? If you really learn this one, no? Therefore you will be very thorough in the concept. So let us go to our topic, right? So let us see, this is our first question, right? So here which of the following is not possible? That means here each and every question, no, there is a learning thing is there. So one information you will get it, no. Like that you have to solve the problems, as many problems, no, as much you can, so that each and every problem you will be learning one new point in that, right? So that's why doing the problems in the physics, no, is must and should, no, right? So here we will see, you know, therefore which of the following charges are not possible? Not possible means what? Q value is equals to N into E. So this N should be integer. That means, so here N should be a number. N should be equal to 0, 1, 2, 3, 4, so on to things, no? But it should not be like a, so it should not be 1 by 2, half electron, 3/4 electron, right? Like that. Therefore, this 3/4 electron or 1/4 electron, these all are not possible. Correct? So therefore, be careful. If it is a correct number, if you are getting, no, therefore it is a possible one, right? So this is one learning thing in this one, no? Let us see here. First one is what? It is root 3e. Root 3 means what? Root 3 is nothing but 1.7. So Q is equals to 1.7 into E. So 1.7 charge will not be possible, no? Therefore this is not possible. Root 3 times of E is not possible. So now next, what about this one of 48 into 10 to the power of minus 19? So let us see here, no? Therefore N is equals to, so Q by E. Therefore 48 into 10 to the power of minus 19. Charge of the electron, no, 1.6 into 10 to the power of minus 19 coulomb. So this will cancel here, no? Therefore here how much will be? 480 divided by 16. 4 4s are 420s are, therefore 4 1s are 430s are. Therefore N value got it as perfect 30 electrons, no? 30 electrons carries this much amount of charge, no? So therefore this charge, no, is possible. Clear? And let us solve this one, no? Therefore 3.2 So whether it is possible or not, no, let us check this one now. Clear? Now let us see 3.2, this is possible or not. So here third one, no, therefore here n is equals to q by e. So 3.2 into 10 the power of minus 20, so 1.6 into 10 the power of minus 19. So therefore this it will get it as 2 times, so this it will be 10 to minus 1, no, therefore 2 into 10 the power of minus 1. Most of the students, no, they will think that this is possible, 2 is there, no, no. Why? Because 0.2, so 0.2 electron is not possible. So therefore the charge here, no, this one is not possible. Clear? So now therefore here 1 coulomb, therefore here fourth one, no, so 1 coulomb of charge, no, therefore n is equals to, so 1 by therefore 1.6 into 10 the power of minus 19. So therefore 6.25 into 10 the power of, so therefore 18. So most of the students what they will think, no, 6.25, no sir, no, here 10 the power of 18 means what, 625 into 10 the power of 16 electrons. So this is the perfect number. So therefore 1 coulomb of charge is possible, like this. So here you will learn in this question, no, so quantization of your charges. So like that each and every question, no, there is a learning thing is there. So right, so try to learn all these different model questions, no, so that you will be perfect in the physics, so that so physics will become like a very easy. Correct? So let us see. So one more question here, no. Right. So there is a minus 10 coulomb of charge is there, no. A body has minus 10 coulomb of charge. If 3 into 10 the power of 20 electrons are removed from this, then find a new charge. See, therefore, now if you from any one body, no, therefore if you remove these electrons, no, what will happen now? It will become like a positive charge. Correct? So therefore now by removing this many electrons are there, no, so how much amount of new charge? Already there is a charge is there, minus 10 coulomb, no. Let us see here, no, therefore upon to this one, no, minus 10 coulomb charge is there, no. So by removing this, how much amount of positive charge it will gain, no, we will find it, then we will add this one now. Clear? So this will become like a positively charged. Now let us see what is the charge here now, n into e. Therefore n is how much now? 3 into 10 to the power of 20 into 1.6 into 10 to the power of minus 19. So this 20 minus 19 means 1. So 3 into 1, 16 now. 18, so 48. So 48 coulomb, right? So plus 48 coulomb it will be takes place onto this, right? So plus 48 coulomb. Therefore here what will be the total charge on this one? No, total charge it will be already minus 10 coulomb is there, plus 48 coulomb. So 48 coulomb. So how much it will be now? So subtract it, no. Therefore plus 38 coulomb is a charge it is going to gain it now. Clear? So in this learning, no, in this question you will be learning if there is a loss of electrons are there, no. So therefore you will be gaining the positive charge, right? And also additive property of these charges now, right? So now let us go for one more question here, no. Right. So here 10 to the power of 10 alpha particles are ejected per second from the body. That means there is one body is there. From that 10 to the power of 10 alpha particles are emitted now, ejected from the body. Then after how much time the body will acquire the, so therefore here 8 microcoulomb charge now. Therefore here what you can write it now? So per second, therefore you can know that. So therefore number of electrons, number of charge particles into charge of your alpha, right? What is the charge of your alpha? Charge is nothing, alpha particle is nothing but a helium nuclei. That means plus 2e, therefore 2 into 1.6 into 10 to the power of minus 19 coulomb. This is the charge of the alpha, right? So this is by time, therefore by time, no? So therefore 10 to the power of 10 alpha particles are emitted per second onto this. So how much time you require now? Therefore here q how much it is given now? Therefore, here it will be 8 into 10 to the power of minus 6 divided by time. It will be equal to number of electrons ejected per second. I mean number of alpha particles ejected per second. No? Therefore, 10 to the power of 10 divided by 1 into charge of this one. No? 2 into 1.6 into 10 to the power of minus 19. So, then calculate for t. No? This 10 to the power of minus 19. So, minus 19 plus 1. No? Therefore, t is equals to 8 into 10 to the power of minus 6. So, divided by 2 into 1.6 into 10 to the power of minus 9. This taken here. No? So, therefore, 8 into 10 to the power of 9 minus 6 means is nothing but 3 divided by 2 into, so 1.6 means 16 into 10. So, 8 ones are 8 twos are, so 2 ones are 2 fives are. So, therefore, here it will be also 500. So, 1000 means therefore, it will be the 500. So, 500, so 25 therefore seconds. So, 2500 seconds now, clear. So, in this way you can calculate this problem, no, right. Now, let us go for this one more question here, no. So, okay, right, this is slightly one new concept here, no, which I did not covered in the first part, no. So, here therefore, here it is, suppose here one learning thing is there, no. Suppose this is one find the final charge on the spheres when the switch is closed. So, when this sphere is, this also both are identical. So, 60 and 60 plus 0 divided by 2, you would have got it as 30 and 30. But what happened now? Here this spheres are different. Then how to solve the charges on this one now? Therefore, initially what are the charges are there now? Therefore, charge Q1. So, here Q2 was 0. Finally, therefore, suppose Q1 and Q2 it will be gain now, clear. So, now you know that therefore, Q1 initially how much charge is there now? Final also that much charge it will be there. So, initially how much now? 60 microcoulomb, therefore, microcoulomb, this is 0, 60 plus, therefore, it will be this one. So, here we know that the charge which is right, which is occupied on this one now, so it is directly proportional to the radius, therefore, Q is directly proportional to the radius. Suppose this is R1 is the radius and R2 is the radius, you can write down Q1 by Q2 is equals to R1 by R2. What is given now? Therefore, here R1 is nothing but a 2 divided by 3. So, therefore, Q1 by Q2 should be equal to 2 divided by 3. But Q1 plus Q2 is equals to this one, no? Therefore, I can write down Q1 taken common, no? 1 plus Q2 by Q1 is equals to 60 microcoulomb, clear? Because I take the common now. So, here Q2 by Q1 is nothing but a, so Q1 into 1 plus Q2 by Q1 means is nothing but a 3 by 2, it will be equal to 60 microcoulomb. So, this how much now? Q1 into 5 by 2 is equals to 60 microcoulomb. Therefore, Q1 is equals to 60 microcoulomb into 2 by 5. 5 ones are, therefore 5. So, 12s are, therefore, it will be 24 microcoulomb. So, upon to this one, no, therefore, final charge it will be equal to 24 microcoulomb, no. So, therefore, here, so in this one now, this 24 is remaining charge it will be how much now? So, therefore, similarly you can calculate it onto this one, no, or Q1 already I know it, no, therefore, minus 24. How much it will be? Minus 24 now, minus 24, therefore, this is 6, no. So, this is 5, therefore, 36. Therefore, it will be 36 microcoulomb. So, even you can solve this one, no, therefore, by using this method, right. So, same method, no, you can calculate it. So, clear? So, in this way, you need to solve the problem now, right. Yeah, same type of question, no, but slight change it is there now. What is given now? Q1 is given, how much it will be? 60 microcoulomb. Q2 is given, how much now? Minus 100, minus 100. Again it is closed, therefore, the same thing, no. So, initially how much charge was there, no? So finally also how that much amount of charge only it will be present here, no? So then we can rewrite it as, so Q1 plus Q2 is equals to Q1 plus Q2 is equals to, therefore 60 minus 100 minus 40 microcoulomb. Clear? So then again you know it, no? So Q1 by Q2 is equals to R1 by R2, R1 by R2, it will be equal to 2 by 3. So therefore substitute in this one, no? Try to solve this method, no? So here new learning thing is what? This one, no? Clear? In this way you can solve the problem, no? So you can continue. I'm not continuing this one, no? So just like previous one, no? Therefore can continue this question. Clear? Right. Now let us see one more question, no? This is a simple question, no? Simple formula. Calculate the force between the two charges, no? Each of 1 microcoulomb is separated by, this is simple substitution, no? Therefore 9 into 10 to the power of 9 into each 1 microcoulomb, no? 1 microcoulomb. 1 microcoulomb means 10 to the power of minus 6 into 10 to the power of minus 6 divided by 1 centimeter, 10 to the power of minus 2 whole square means 10 to the power of minus 2. So how much it will be? This taken here, no? 4, this also 4, this is 8, therefore 1, so therefore 90, so newtons will be your answer. Clear? Yeah. Now try to understand this question, no? It's a very simple one, no? Therefore there are identical spheres are there. This is A and this is B, carrying a same charge, Q and Q. Force between them is, they is separated by distances R. So force between them is how much, no? KQ square by R square in the vacuum. A third sphere is there. There is one third sphere is there of identical sphere. First part is in contact with A, then contact with B, then finally C is taken away. Okay. Now what happened now? First C is coming, no? Here this is C. Now it is contacted. Identical spheres, no? Identical spheres means what will happen now? The charges will become like a half of this. Final charge what will happen now? Q by 2 and Q by 2. Now this is taken to here and again it is in contacted with this one, no? Therefore this it will become, this is already Q by 2 is there, this having the Q. What will be this one now? Q plus Q by 2 divided by 2. Therefore 3Q by 4. Therefore this it will become like a 3Q by 4. This it will become like a 3Q by 4. And this is now removed here now. This is taken out. Now the new force between them, no? What will be the new force between them? Here, therefore it will be Q by 2, 3Q by 4. Therefore it is R. Force between them is nothing but a K into Q by 2 into 3Q by 4 by R square. Clear? So therefore 3 by 8 KQ square by R square. Therefore 3 by 8 into F. So will be your answer. Right, 3 by 8 into F. Clear? So understand the question. So solving is very, very simple. Now, yeah, similar type of question, no? Let us see. Two spheres having equal charges exerts force, F force each other. So now 20% of one sphere is transferred to another sphere. Now find the new force, right? So here again, same situation, no? This is Q, equal charges. This is also Q, having separated by distances R. Now the force between them is how much now? KQ square by R square. Now what happened now? From this one now, 20% Q is given to this. That means, so what will happen now? This charge now, this new charge now, Q minus 20 by 100 into Q. How much it will be? So therefore it will become like a 4q by 5 for this one, first sphere. No, it is added q plus, so q by 5, that is nothing but a 6q by 5. Clear? So now therefore the same spheres, no, so what will happen now, 4q by 5 separated by same distance, no, therefore 6q by 5. What will be the force between them now? Again k into 4q by 5 into 6q by 5 by r square. How much it will be? 12, 12, 24. 24 by 25 kq square by r square. Therefore 24 by 25 into f. Right? So new force, what will happen now? Here it will become like a 24 by 25 into f. Clear? Okay. Now let us go for one more question now. Here two spheres of having equal and opposite charge. Here opposite charges, exactly the same, no? Therefore it is having q, but it is having minus q. Again 20% is transferred here, no? Right. This will happen how much, no? Q minus q by 5. So how much it will be? Therefore 4q by 5. Here what will happen now? Minus q plus q by 5 minus 4q by 5. So therefore they undergo like a force of attraction onto this one, no? Now new force. What will be the new force now? K into 4q by 5 into 4q by 5 by r square. Clear? So 16 by 25 kq square by r square. So it will be f. Clear? So even sign changes, no? So definitely the answer also is going to change. That's why you should be very careful in the sign of our charges now. Clear? Now let us go for this one. So this is one of your JEE main and NEET question, no? So many times this question is asked, no, in the examination, no? So there are two spheres of equal charges are kept at long distance, very long distance. The gravitational force between the spheres is equal to electrostatic force between them now, right? See here, what happened now? There is a two equal spheres having the charge q and having charge q. So what will happen now? They undergo like a repulsion here, no? They will undergo like a repulsion. Why? Force because of due to the charge, no? So how much now? Kq square by r square. But they will be having again one more force is there, that is nothing but a attraction force. What is that? Gravitational force. What is the gravitational force now? G m square by r square. Identical one now. Two equal charges, right? So therefore you can take it as identical, no? So these forces are equal. Therefore this is electrostatic force, this is gravitational force. So what is given now? Gravitational force and electrostatic force is equal. So G m square by r square is equals to, so q k q square by r square. Get cancel out, no? So that implies q by m, no? Therefore taken now G into m square, it is equals to q square by 4 pi epsilon naught. Taken here, no? G into 4 pi epsilon naught, it will be equal to q by m whole square. Therefore here q by m, it will be equal to root of g into 4 pi epsilon naught. Clear? So in this way you can solve the problem, no? Right? So very important question. So mostly they are asked in the NEET and JEE mains, no? So please observe this question, no? Clear? Now let us see here, no? So this question, a 12 coulomb of charge is distributed among the two spheres separated by 2 meters. Find the charge on the each one, so that the coulombic force between the maximum, and also find the maximum force. See, I already told you. See here, therefore suppose here total charge is how much now? See, you can remember that suppose on this sphere, no, there is a 12 coulombic charge is then, no. This can be split here, no, therefore, so that the force between them is maximum. force it will be the maximum. So when it will be equal to Q1 into Q2. When the product is more, then it will be the maximum. Suppose I can write down 1 into 12. So what will happen now? Here it is 12 will become now. So I can write down 2 into. So therefore 2 into 10. Therefore what will happen now? 20. So because add means it is going to get now. 3 into. Therefore it will be how much now? 27. Like this if you continue no. So you can get it as 6 into 6 no. 36. Therefore here it will be the maximum. So here two learnings are there no. Here is maximum. Here it is a minimum. Suppose they are asking for maximum no. Maximum means what we should have now here. Therefore 6 coulomb and 6 coulomb should be there. That means 6 and 6. That means equally divided. So divided by 2. Then only the force it will be maximum here now. Force it will be maximum. Here what will happen now? Force it will be minimum. Clear? So remember that. So first one 1 into 12 the force will be minimum, and second one no, therefore force it will be the maximum. Again you can see the other further combinations no. So it will be not getting onto this one no. So he is asking maximum only. So therefore the charges on each sphere it will be how much no? The charges on each sphere it will be equal to how much no? 6 coulomb and 6 coulomb. So what will be the maximum force here no? What will be the maximum no? So maximum it will be equal to, so 9 into 10 the power of 9 into 6 coulomb into 6 coulomb divided by 2 into 2. Therefore it is 3. Therefore it is 3. So 9 9s are 81 into 10 the power of 9 newtons. So 81 into 10 the power of 9 newtons. This is your maximum force. So they may ask you, so what will be the minimum force no? So minimum force no. Therefore you can combine this one no. Then you can calculate it now, right? They did not give, but you can learn this one now. So 1 into 12 divided by 2 into 2. So therefore it will be 6. Therefore 3, 9 3s are 27 into 10 the power of 9. This it will be a minimum force between the two spheres. Clear? So now, right, like this you should understand the question no. Each and every question will give a lot of information for you. Okay, so try to learn these questions so that you will get the thorough in the concept onto this. Correct? So a particle of mass m carrying a charge q1 is revolving around a fixed charge of minus q2 in a circular orbit of radius is r. So therefore calculate the period of revolution and its speed also. Here this is also one important question no. So there is a minus q1 is there, q2 is there. So this is fixed now. Here there is a one charge is revolving onto this one no. Right. Therefore here there is a one charge is there no. Therefore it will be minus q2. Clear? Here it is q1 is revolving now. Therefore with some speed. So here it is at a distance is r from this one. Clear? So we want to calculate the time period no. So time period means circular motion means immediately you should get into your mind, that is centripetal forces now, right, and centrifugal forces. So this is your Coulombic force of attraction. So will be balanced by the centrifugal force no. So Coulombic force is how much no? What is the Coulombic force here no? F E and centrifugal force no. Therefore here time period no, m r omega square. So k q square by r square. Clear? So you can rewrite this one no. Therefore you can combine it no. Therefore m r omega square it will be equal to k q square by r square. Therefore here omega means what you can write it now, that is nothing but a 2 pi by t whole square. So omega, therefore k q square by m r q. Clear? Therefore you can write it as root here no. Therefore 2 pi by t it will be equal to root. Therefore q square by, therefore 4 pi epsilon naught m into rq. Therefore t is equals to, so 2 pi into, so 4 pi epsilon naught m r cube by q square. So this it will be your time period of this one. Clear? Clear? So and also speed you can calculate it, no? Therefore what will be the speed here, no? So mv square by r, you can use the same formula here, mv square by r. So you can rewrite the same formula here, no? Right. Right. Therefore here, so mv square by r, it will be equal to, so q square by, therefore 4 pi epsilon naught into r square. Clear? So this one get cancel out, no? So v square is equals to q square by 4 pi epsilon naught into mr. So v is equals to root of q square by, therefore 4 pi epsilon naught into mr. This is here the speed of this. Clear? So in this way, right? So you need to understand simple questions, no? Simple concepts, easily you can solve it, no? Right. So find the net force acting on the charge placed at B. So here these type of questions, no, already I covered in first part, no. So just go through it, no. Right. If you want, I will discuss any question here, no. So this question we can go it, no. Therefore here, so this is Q. I already discussed in the first part 1, no. So again discussion it is, therefore it's a waste of time, no. So therefore please go through it. So this is your same charges, no. It will be kq square by r a square, no. So this also it will be kq square by a square. Therefore this angle is 60 degree. So this angle is 60 degree because equilateral triangle. So when the two identical forces are there, same, no, making an angle 60 degree, therefore root 3 into F. So force acting on a particle at B, it will be equal to root 3 into k q square by a square. So this is your force acting on the particle, no. But here this is negative charge is there, here positive charge is there, here negative charge is there, no. So be careful on this one, no, so that here this positive and negative, therefore it will be experiencing force toward this side, it will be experiencing force toward this side, like this. Okay, so this is your experiencing a force toward this side, no, attraction force, here repulsion force, here 120 degree. I already discussed the same question in the part 1, please check out this question now. Yeah, these type of questions also I discussed in the part 1 now, please check out it, no. Therefore for this purpose I will discuss one question here, no. So find the net force acting on the charge which is placed at B. So therefore we will discuss this question, no, slightly different is there, no, we will discuss on this one B. So what you can write in now, here this is minus Q, this it will be the plus Q, minus Q, therefore it is A, some distance is there, A and A. So we want to calculate the force acting on this one, no? Therefore what will be the force acting on this one now? Here minus Q, here plus Q, means what will happen now? Attraction force. So that is nothing but kq square by a square, plus Q and minus Q, therefore attraction force kq square by again a square. So this is your minus and minus. So this force it will be a repulsion force kq square by r a square, no. Therefore no need to think about the negative and positive, no. Because we are already doing this negative and positive attraction and repulsion, no. So that here only it will be over now. Therefore here this force, no, these two forces are acting toward this side, then you can get it as resultant force toward, because of due to this one, no, it will get it as like a, sorry, this is not a square, because this distance is nothing but a root 2 into a. Therefore this is root 2 into a, so therefore 2a square will be our answer, right. So but here because of due to these two forces, no, therefore root 2, because angle is 90 degree here, no, therefore when two identical forces are acting at 90 degree, it will be root 2 into f. So let us write down root 2 into kq square by a square, this force, no, and this force is kq square by a 2a square, which is greater here now. So root 2 into F, no, this is only the greater, no, compared to this. Therefore force on this one, it will be equal to kq square by 2a square. Therefore net force acting on this one, no, you can write it as kq square by a square. Therefore root 2 minus 1 by 2, so which is acting toward this side. Like this you have to solve the problems, no. So try to do this question and this question, no, so that you can understand clearly, right. So you have to try different varieties of questions, then only you will become perfect in that. Clear? So right here one learning is there, no, in this point, no, most important point. Therefore find the net force acting on a charge q placed at point P. Right, very important point here, no, we are going to learn here, no. So here these two are identical charges and kept at same distance, midpoint, no. So if you keep a charge q here, so what will happen now? Here q is there, therefore here it will be the q is there, it is at midpoint, q is there. What will happen now? Identical charges, no. So therefore this side it will go into experience of force because of repulsion, and this repulsion, same product same distance, same product same distance. This side force and this side force both are equal, force acting on this one it will be equal to 0. Right, here also it is centroid, no, therefore force it will be equal to 0. Here also centroid, no. So here if a charges are uniformly distributed, identical, right, so identical charges uniformly distributed in geometrical pattern, geometrical pattern at geometrical center, therefore if you keep any charge, no, so at geometrical center electric field will be 0 and the force experienced by the charge which is kept at it will be equal to 0. So this is the important learning, no. So based on this, right, so most important concept, no. So try to remember these all are uniformly distributed. Suppose if it is given positive and negative, therefore force it will be the not 0. Here somewhere here it will be negative, means force it will be not 0 onto this, right. So that's why be careful, no, all similar charges should be there and arranged so in the geometrical pattern. So therefore their geometrical center, so therefore the force it will be equal to 0. Why? Because electric field is also equal to 0. This point is very important. Clear? Now equilibrium. So when there is an equilibrium word is there, no, immediately you should get into your mind, therefore net force should be equal to 0. That's all. This is the point you need to learn here. Equilibrium means net force it will be equal to 0. Clear? So is asking what? Find the value of charge to be placed at the center of the system, no, so that system will be under equilibrium. Equilibrium means what you have to do now? I will do this question, no, therefore do this question, right. So here what is given now? This one charge is given, no. So charge is given, no, q, right. Therefore this is A, this is A, this is A. What happened now? These two are, so repulsion, no, therefore it will be going on to this kq square by a square. So these two are repulsion, no, kq square by a square. Therefore this angle is 60 degree. It is nothing but a root 3 kq square by a square, right. So this side is a force, net force acting on this one, no. That means here we have to keep one charge here, no. So here one charge you have to keep at the centroid onto this. Suppose one charge you have to keep it now, so that the force acting on this one should be equal to 0. Clear? So what is this distance now? This distance you can rewrite it as, this distance is also same, this angle is 30 degree. So therefore this we can rewrite it as, it's a by 2, this is your x, no. Therefore cos 30 it will be equal to a by 2 by adjacent side by hypotenuse. A by root cos 30 is nothing but a root 3 by 2, it will be a by 2x, this get cancelled, x is equals to a by root 3. So what is this distance now? A by root 3. So compulsory this is your repulsion is there, no, this should be experiencing toward this force, no, compulsory this should be negative. Clear? So therefore this side force is how much now? What is this force now? Force toward this side is nothing but a K into Q by, so A by root 3 whole square means, so A square into 3. So this is your force, no, and this is your resultant force. Therefore if both are equal, then only the force it will become to the 0, it will be under equilibrium now. So these two forces, this force and this force should be equal, that means 3kq into q by A square is equals to root 3 k q square by A square. This will get cancelled out, no, 1q get cancelled out, no, k get cancelled out, no. So here q should be equal to 3q by, therefore root 3 into q. So negative charge, no, therefore here at this point at the center, no, so what you have to calculate, what you have to keep the charge, no, so q is equals to minus root 3 into q, this much amount of charge you have to keep it at the center. I think you understood, no. So similarly you can try this question, so as your work, right. So try to observe these right concepts, no, so that you will be having lot of learning thing in this one now. Clear? Now we'll do one more question, no, slightly right lengthier concept is there, no, this one, no, let us see, try to understand this question, no. So what is given here now? Therefore here two identical charges are there, two identical charge spheres here now, right, suspended by the string onto this of equal lengths, therefore lengths are same. So the strings makes an angle theta, right, with a vertical. So suspended in the liquid, so sigma, when suspended in the liquid, the angle remains same, therefore this theta is also remains same. What will be the dielectric constant of the liquid now? Therefore density of the material is given, density of this one now is given onto this. So when they are kept in this one now, right. So when they are kept in the air, therefore theta is also same. So even when they are kept in the water, in the liquid, also theta will be the same. So first of all let us calculate this situation now in the air or vacuum. So what will happen now? Therefore these are having identical charges now. Therefore what will be the distance now? This distance is L. So this distance it will be equal to how much now? Theta. Therefore the sin theta. So sin theta is equals to this distance. Therefore suppose x, no, x by L. So L sin theta. Therefore this distance it will be equal to L sin theta and this also L sin theta. Clear? Clear? So therefore the force between them, this side force and this side, no. So here you can got it everything, no. This is tension, no, tension T cos theta, T sin theta, no. So T cos theta is balancing the mg. So T sin theta, okay. Right. So T sin theta, so it is balancing that this Coulombic force now. What is the force here now? That is nothing but a k into, okay. So this distance is also k, charges are same, q square. So that is nothing but a k1 is nothing but how much, no, q square by 4 pi epsilon naught into, suppose this is here r, you can take it, no, r square, right, because theta is also same, the distance between them is also same. So what you can write it now? Therefore here tan theta, therefore you can divide these two, therefore here tension cancel, no, tan theta is equals to how much it will be now? So therefore q square by 4 pi epsilon naught into r square into mg. Clear? Clear? So now when they are kept in the liquid, liquid means what will happen now? This is like a liquid now, right? So liquid means what will happen now? Here the weight will not be like a mg, the weight will be equal to like a apparent weight onto this. What is an apparent weight now? Therefore you can rewrite it as, so when they are kept in the liquid, no, apparent weight it will be equal to mg into 1 minus density of the liquid by density of the body, right, density of the body. Clear? So this it will be your apparent weight when they are kept in the liquid now. Therefore now let us rewrite this one now, same concept, no. So here t sin theta it will be equal to q square by 4 pi epsilon naught into k. Why? Because epsilon r it will be equal to epsilon by epsilon naught. That is nothing but a dielectric constant k, right? So k into r square when they are kept in the medium. So therefore t cos theta it will be equal to, so therefore mg into density, therefore 1 minus density of the liquid by density of your bomb. Clear? So again you can cancel it, no? So here therefore tan theta, what you can write it now? Therefore q square by 4 pi epsilon naught into k into r square. Therefore it will be mg into 1 minus density of the liquid by density of the bomb. Clear? So angles are same, that means this should be same compulsory. So then this should be the same, no? Therefore here it is q square by 4 pi epsilon naught into k into r square into mg into 1 minus density of the liquid by density of the bomb. It will be equal to q square by 4 pi epsilon naught into r square into mg. So this will get cancelled, 4 pi epsilon naught mg. So this everything it will get cancelled out here. Yes or no? So therefore here that I will take it as k is equals to 1 by 1 minus density of the liquid by density of the bomb, right? So simple formula you got it, no? Then so what will be the density of the liquid, no? Right, density of the liquid is 0.8, density of the bomb is 1.6. Okay, right? Therefore k is equals to, so 1 by 1 minus density of the liquid is how much now? 0.8 by 1.6 means 1 how much now? 1 by 2. So therefore 1 by 1 minus 1 by 2. So therefore here 2, therefore 2 by 1, therefore dielectric constant it will be equal to 2. Clear? So looks when the question is there, no, it looks very difficult onto this one, how to do it, no? But once you start doing these concepts, no, therefore you can solve the problems very easily. Clear? Now let us see one more question, no, one more concept, no, similar type, no, right? Find the tension and the charge on both bodies, both have equal and opposite charges now. So equal and opposite, q we have to calculate, tension also we have to calculate. So this distance is L, so therefore you can write down the free body diagram for this one, no, right? So it is making an angle of 30 degree here now. Clear? So then we can rewrite it as, therefore it is experiencing a force here, no? So this is F and this force it will be equal to mg. So this is your tension here, no? Therefore here tension, so you can class therefore this is nothing but t sin theta, therefore this is your t cos theta. That implies what? T cos theta is making like a mg here now. Therefore here t cos theta is nothing but a, so 30 degree here now, theta is nothing but a 30 degree. Clear? Huh? So 30 degree means how much now? It is root 3 by 2 mg. Therefore tension is equals to 2 mg by root 3. This is your tension. Clear? Huh? So charges means what you can write it now? Force. Force it will be equal to how much now? kq square by L square, that means 1 by 4 pi epsilon naught into q square by, therefore L square, distance between them is given as L, right? So this it will be equal to tension into sin 30. Clear? So therefore here, so here is asking the charge, no? So q square by, therefore 4 pi epsilon naught into L square is equals to, tension is equals to 2 mg by root 3 into 30 is nothing but 1 by 2. Therefore get cancel out, no? So taken here, no, q square is equals to mg into 4 pi epsilon naught into L square by root 3. So this is square is there, no, therefore you can apply the root. So this is a charge, right, on this one now, right? Clear? So very simple question, no? Right? So then we can go for one more question. No? Right. A small charge is there, q of mass m is in equilibrium at a distance is d. Distance and equilibrium d distance. Above another charge q, what should be the value of q in terms of the given quantities now? Therefore, here what is given now? There is a simple question now. This is one capital Q is given now. This is one now. Okay, small charge q is placed under equilibrium above, right? Sorry. So therefore, here what is given now? There is a capital Q is there, capital Q. What it will do now? Therefore, here one small q is there. So it is said that it is under equilibrium. Equilibrium, immediately total force it will be equal to 0. That means, so total, right? So what are the forces will be there now? It's having mass m. So downward force is there mg. So distance is d. Your distance is d now. Therefore, this downward force is balanced by this one, no? That is nothing but k capital Q into small q by d square. Therefore, k is nothing but 1 by 4 pi epsilon naught into capital Q into small q by d square. It will be equal to mg. So he is asking what a q, no? Q, therefore q is equals to mg into 4 pi epsilon naught into d square by, therefore it is capital Q, it will be there. Clear? Huh? So this should be your, this is your q. Clear? So very simple one, no? Yeah, this type of questions already I did in our part 1 video. Please check out that video, right? So but here we'll give some one more time we'll do it, no? So that in the given case, where should be the third charge q must be placed, so that net force acting on the third charge will be the 0. 0 means nothing but a null point. Clear? So please check out that video. So here one more thing you need to observe it now. Therefore here it is E is there, here minus E is there. Suppose if you are keeping here, what will happen now? If you keep here, what will happen now? So this is positive and positive, therefore repulsion, no? This negative and positive attraction. If both the forces are acting in same direction, no? So net force will never be 0. Clear? Therefore, in between these two charges, no, it is impossible to get the null point. So where you have to place it now? Therefore here you have to place, that is x, q. So this is x, therefore this distance it will be equal to 20 plus x. Clear? So why? This is positive repulsion, no? This is positive and negative, this is your attraction here. No? Clear? So therefore what you will get it now? So repulsion, no? Therefore k into q into E by x square is equals to k into, therefore 9E into, therefore 9E into q by 20 plus x whole square. This will get cancelled out, no? Clear? So 1, therefore 1 by x whole square is equals to 3 by 20 plus x whole square. Clear? So therefore it will be equal to 1 by x is equals to 3 by 20 plus x. Taken here, no? 20 plus x is equals to 3x. So taken here, no? 20 is equals to 2x, x is equals to 10 centimeter. So therefore this value it will be equal to 10 centimeter. So also do the question, no? Suppose here it is plus and this also plus, no? So then plus and plus, no? Therefore the charge you have to keep it in between them, no? So that you will get the null point, right? So this is one of your new learning, no? Now let us see here, no? So therefore here right, let us see here, no? Therefore what is given here now? The question here, no? Therefore here plus q and plus q are there. This is q and q, you have to keep it now, right? what equal charges should be placed on the remaining parts of this one, no? So that net force on the plus q will become to the 0. So the force on this one, no, should becomes to the 0. The same thing, right? You can try it, no? So this is your right. So these two are same charges, no? Therefore it will undergo like a repulsion, k q square by root 2, therefore 2 a square. Compulsory this side force is there, no? Compulsory this side force should be there, compulsory this should be negative, negative. Then what will happen now? K into capital Q into small q by a square, therefore k capital Q into small q, so by a square. So this it should be equal to root 2 into f. Therefore what you will get it now? Therefore root 2 into, therefore kq square by kq into q by a square is equals to, so therefore k into q square by, therefore 2a square. kq get cancel out, no? A square and a square get cancel out, no? q is equals to q by 2 root 2. So but should be compulsory minus. So which is your answer, no? So fourth option will be your correct answer. Clear? Now let us see one more charge, no? One more question, no? So two charges of each magnitude q are fixed at 2a distance, no? A third charge minus q m placed at the midpoint of the two charges. When q is slightly displaced perpendicular to the line joining the charges, no? Then find the time period. This is one of your JEE main question, no? So let us see here, no? There is a one capital Q is there. This it will be at distance of capital Q. This is A and A. Here what we are going to do now? Here we are going to keep it as minus Q. Therefore this it will be get displaced here now. Clear? So small displacement. This displacement is, suppose it is x, right? So when it is come to here, what will happen now? Means come to there, no? So what will happen now? Therefore this it will be equal to, this distance is nothing but a root of a square plus x square. So what will happen now? This it will be undergo like a attraction force here, no? So this also will undergo like a attraction force. Clear? So therefore what will happen now? This will go down. This will be, right, experience a force like this. So the resultant force it will be acting toward this end. Then it will come to here, no? Therefore force it will become to the 0, and then further it will go like this. Then it will come back. Go like this and come back now. This is nothing but a simple harmonic motion. Simple harmonic motion, I already did one video. 3 videos are there based on oscillations, no? Simple harmonic motion means immediately should get into your mind. Simple harmonic motion means what? Acceleration should be equal to minus omega square into x. You have to calculate the acceleration. That's all. Acceleration is compulsory, you require the force. Now let us see what is the force here now. This force, this is your theta. This force, no? So this is F. What you can write it now? F is equals to K into capital Q into small q divided by, what is this one now? This is a square plus x square. Root means whole square get cancelled. Therefore this is theta, or you can take it as this instead of this theta, no? Therefore you can take it as this is your theta. So this is your force, no? This is your force. Then you can split this one, no? This is, it will become like a f sin theta and f cos theta. This side it will be the f sin theta. This side also f sin theta. These two are getting nullified onto this one, no? This it will be there, no? Therefore total net force net force, no? Therefore 2 f cos theta. 2 f is how much now? kq into small q by a square plus x square. Cos theta is how much now? Cos theta is nothing but adjacent side by hypotenuse, no? That is nothing but x by root of a square plus x square. This is a force, no? Let us simplify this one, no? Therefore, here 2k capital Q small q by, therefore, a square plus x square power 1 by 2 to the power of 1 plus 1 by 2 is nothing but into x. This is your restoring force, no? It is coming back. Here we can see that, right? So, therefore, this is a restoring force, no? So, force is equals to mass into acceleration. But for a small displacement, no, that means x is very smaller than this is your a. So, when x is smaller than this one, no, therefore, x square term, no, it will be can be neglected here now. So, then you can rewrite it as, no. So, m a, it will be equal to 2k into capital Q small q by, therefore, it will be a square, x square can be neglected, no. A square to the power of 3 by 2 means what you will get it now? A cube into x. Clear? So, x square, see, x is smaller means x square it will be still more smaller onto this one. So, that is why x square only can be neglected, not here x onto this, right? So, here it will be acceleration is, this is a restoring force, no, minus only. So, minus, therefore, 2q into q, k value is 4 pi epsilon naught into m into a cube into x. So, how it is looks like now? Exactly our simple harmonic equation here now. Therefore, here like this. So, what will happen now? Therefore, here you can rewrite it as omega square, it will be equal to 2, okay, 2 means you can write it as again 2. So, therefore, this 2 can be neglected here now again. So, q into q by 2 pi epsilon naught into m into a cube. Clear? So, then omega square, no, this is a root. So, this it will be equal to 2 pi by t. So, this is q into q by 2 pi epsilon naught into m into a cube. So, this is taken here now, t is equals to 2 pi into root of 2 pi epsilon naught m into a cube by capital Q into small q, taken here now. So, 4 pi square, 4 means t is equals to whole root, therefore, 8 pi cube epsilon naught m a cube by capital Q into small q. So, this is your time period. Understood? So, in this way you can solve the problems, no, very easily, right. So, try to observe this one, no, then you can able to solve the problems. See, I think you are learning this one, no, by learning of different questions, no. So, you will be learning new things onto this, right. So, now let us see one more situation here, no. Therefore, in a given 3-point system, no, find the time period of a central charge, no, if q and of having mass m displaced slightly along the line joining the two charges. Therefore, here the same type of question, no. So, slightly this charge, no, what you are doing, mass is m, this is slightly moved some x distance. So, what will happen now when it comes to here? So, therefore, when it comes to here, no, so this is already positive charge, no, this side force it will be more onto this one, no, compared to this side force, no. So, therefore, net force it will be acting. Therefore, while going toward this side, net deceleration takes place onto this one, no, it will go toward this side and go toward this side, go toward this side. Clear? So, therefore, this also it will be undergo in the form of a like a simple harmonic motion. Here the force it will be equal to 0. Clear? So, this also is nothing but a simple harmonic motion, SHM. So, SHM means immediately you should get it in your mind, A is equals to minus omega square x. Clear? Clear? So, now I think you can try this question now. So, here it is q is there. Here there is a one small charge is there, no. Therefore, here it will be q charge is there, no, q charge, right. So, therefore, suppose it is travelled some x distance. So, what is this distance now? Therefore, a plus x distance here, no. So, this it will be equal to a minus x distance. So, at this point the force it will be toward this side, force it will be toward this side. This side force is more, this is F1 and F2. Therefore, net force is equals to F1 minus F2. Therefore, F is equals to how much now? K into Q into small q by A plus x whole square minus K capital Q small q by A minus x whole square. Clear? So, now you can simplify this one, no? Right. So, here K q into small q, you can rewrite it as, therefore, here A square plus x square minus 2ax, no? This side is minus A square minus x square minus 2ax divided by, so A plus x into A minus x, therefore, it will be whole square. Clear? So, just mathematics simple onto this one, no? This will get cancelled out, no? This will get cancelled out. So, K capital Q small q minus 4ax, therefore, divided by A plus, right, A plus B into A minus B. So, what you can write it now? A plus B into A minus B, therefore, nothing but A square minus x square whole square. Clear? So, here we can rewrite it as, so 1 by 4 pi epsilon naught into, therefore, capital Q small q minus, therefore, 4ax divided by, therefore, A square minus x square whole square. So, this is 4 and 4 get cancelled. This is x is small. So, therefore, x square can be neglected. Clear? So, therefore, what will be the force here now? Force, it will be equal to, so here q and small q into A divided by, therefore, pi into epsilon naught. So, therefore, A square, that means A to the power of 4 into x minus, this is q, therefore, it will be equal to MA. So, A is equals to minus capital Q small q by pi epsilon naught m into A cube into x. So, this it will be your omega square. So, therefore, you can rewrite it as omega square is equals to q into q by y, we can write it as A is equals to minus omega square x, simple harmonic motion equation. Clear? So, therefore, pi epsilon naught m into A cube. Therefore, here square is there, no? Therefore, you can write it as root. So, this it will be equal to 2 pi by t. So, t is equals to 2 pi into square root of pi epsilon naught m A cube by capital Q into small q. Taken here, no? So, 4 pi cube into epsilon naught m A cube by capital Q into small q. So, in this way you can solve the problems, no? Therefore, like a simple harmonic motion problems. Right. So, in this way you can solve the problems, no? So, let us see. Yeah, this is one more new like a vector form, no? Let us see here, no? Therefore, there is a charge q1 is there. So, q1 at what point, no? Therefore, to position vector, we can write it as, so this is having r1 vector. What is r1 vector now? 2i plus 4j plus 6k, this one. And one more q2 is there, like a q1 not, it is nothing but a, charge is a, and this charge is b here now. Where it is now r2 vector, it will be equal to I 2j plus 2k. Now, what is asking now? Right? Find the force on A, due to B. That means force on A due to B now. Therefore, this you can rewrite it as like a delta R. So, delta R, what you can write it now? you can write on triangle law vectors R2 plus R2 minus delta R force on A due to B. That means, so what you will get it now? Therefore here what you will get it now? R2 plus delta R, therefore minus R1, it will be equal to 0. Delta R is equals to R1 minus R2. So R1 it will be equal to how much now? Therefore this is nothing but 2I plus 4J plus 6K minus, so I plus 2J plus 2K. Clear na? So what you will get it now? This is your I, so plus 2J plus 4K. This is your delta R, right? So what is the magnitude here now? Magnitude now, therefore it will be root of 1 square plus 2 square plus 4 square, root of 1 plus 4 plus 16, therefore, so what you will get it now? Root 21. So what is the formula here now? We already did this question formula in introduction. I already told you. So what is the formula? Formula is equals to K Q1 Q2 by R cube into delta R vector. Therefore 9 into 10 the power of 9, the charge on A and B. What is the charge on A? 2 microcoulomb and 3 microcoulomb. So therefore 2 into 10 the power of minus 6 into 3 into 10 the power of minus 6 divided by root 21 whole cube into I plus 2J plus 4K. So 6 into 9, 54. It will get it as like a I plus 2J plus 4K. Therefore, here first option will be your correct answer. Clear? Right? This is also one of your new variety question. No? Now let us see one more question. No? So there are 3 charges are there, 4Q, Q and Q are placed along this one now. Resultant force on Q will be 0 if this is like a equilibrium concept. No? What is given now? Along the x-axis. No? Therefore at this point therefore it will be 4Q at a distance of O, it will be Q L by 2 distance. So here it will be Q L distance, therefore this distance is L. Now the force on Q will be 0. That means upon to this charge, no, force it will be the 0. This is what it will do now. This one, okay, these two are 4Q and Q, no, they are identical. So therefore it will be the repulsion force now due to 1. But this should be compulsory to nullify this one now. Compulsory the force should act toward this side now. So this is F2, F1 now. So what you will get it now? F2 and F1 should be equal, so that net force acting on this one should be equal to 0. So that means F1 should be equal to F2. F1 is how much now? K into Q into 4Q divided by, therefore it is L square because distance, no. Now upon to this distance is also L by 2, right. Therefore here what you will get it now? K into capital Q into small q divided by L by 2 whole square means how much it will be? L square into 4. Therefore this all will become like a same here, no. Therefore Q is equals to Q, therefore it should be the minus Q. So capital Q should be equal to, so minus Q, therefore this first option will be your correct answer. Clear? Right? So therefore here what you will get, so this is also one of your NEET question, very simple question, no? Therefore you can understand this question. See, two small spheres of having the charge q are insulating thread of length is L arranged. In this arrangement, in the space where there is no gravitational effect, the angle between, see, so here there will be one sphere is there, no? This is one sphere. So therefore here also there is one more sphere is there. So what happened now? There is no gravity here, no? So only one force it will be there, that is nothing but a identical one, no? There will be repulsion force. So what will happen now? This charge, no, it will become like this. It will be experiencing a force here, no? Because they are identical. What will be the distance? Distance is nothing but L. So the angle between them is nothing but a 180. The angle between them is 180 degree. So therefore here what will be the force here now? Very simple one, no? Force is equals to 1 by 4 pi epsilon naught into same charge, no? Q square by, this is 2L, therefore 4L square. So 4L square, 2L whole square, no? Therefore you can rewrite it as 2L whole square, 180 degree. First option will be your correct answer now. So in this way you can solve the problems, no? So therefore these are some sample questions, no, which I took it for Coulombic force, no. So see the part 1 and part 2 so that you will get a one full clarity on the Coulombic force, no, so that you can do any type of problems, no? Right. So okay, right. So completed. So thank you for watching. Please subscribe to my channel SADHIK-Physics, no. So which I will make you physics made is very easy, right? So easily you can get it, you can able to solve the problems, no? So slightly some concepts and thoroughly try to watch the videos, no, so that you will become perfect in the physics, no, right? So I will be teaching all the concepts, no, and along with some numericals, so that if you are able to see like a daily, if you spend 1 hour, right? So 1 hour, therefore one video try to watch it, no, try to make a notes, try to understand, so different questions, no, so that you can able to get easily the marks in the physics, no, right? So thank you for watching. Please subscribe to my channel now. Thank you.